hello out there. Welcome today on this beautiful day. Hope you're ready to work. We'll be looking at some statistics, but the focus will be on data handling. And my name is Rakabu. I'll be taking you through some of beautiful statistics with us. Okay. So the focus is 5-number summary. But before we do that, I'd like you to think about something. I'm not sure whether you've ever thought about it. How can one predict the rand to dollar exchange rate in future? Can we really predict? I mean, if the rand is to a dollar is 15 rand, maybe now, can we really predict what does the rand look like in future? What information do you need? Can a different bank come to a different conclusion? You need data. Do you need 10 days data? I think that's little data to predict. You need lots and lots and lots of data to really predict. And sometimes to sketch a line graph and look at the trend of the rand. I mean, you might be traveling overseas and you want the best time to exchange your rand to dollars. Okay, so that's one of the important part of data. Okay, so I hope you've thought about this and how can one predict the rand to dollar. Okay, another thing to think about is how does an insurance company decide on car insurance premium? Okay, I mean, when you buy a new vehicle, a car, especially if you're taking a loan, even not in cash, you have to have an insurance because you'll never know what might happen on the road. That we pay different premium. How does an insurance company decide on that? Actually, they use data also. Okay, I mean, they study where you live. Some company will put a device in your car and check how you drive and really predict your premium. Okay, so data is very important. And it can be in predicting rand, it can be in forecasting your insurance premium. Okay, great, fantastic. So what we're going to look at now is we're going to look at 5-number summary. And under 5-number summary, we'll focus on quartiles. Then look at the box and whisker plot. And so if you look at this, I mean, we have measure of dispersion. Remember that the measure of dispersion, there will be the interquartile and the range. And the measure of central tendency will be your mean and median mode. Okay, they get the cluster around the mean. Okay, so but the focus today will be mainly the measure of dispersion and the 5-number summary. Okay. So we'll look at the interquartile range and semi-interquartile range. Okay. Let's look at some keywords: minimum and maximum. What is a minimum value and what is a maximum value? If given set of data, the lowest value is a minimum value and the highest is the maximum. Why do we care about the minimum and maximum? I mean, they're very important. We can study whether the data is so consistent. Okay, I mean, let's say for your maths results, your test 1, you get 20%, test 3, you get 90%. Your maximum is 90, your minimum is 10. I mean, is that person consistent? I think that's inconsistent. From 10 to 100, one can say you're improving. But let's look at student B. The first test, he get 40%. Then the next test, he get 55%. Oh, the minimum is 40%. The maximum is 55. The deviation between the minimum and maximum is just not too much. I'll say student B is consistent. So it's important to know the minimum and the maximum value of the data, which is the lowest and the highest value of this given set of data. Fantastic. I hope this makes sense. Then let's look at more keywords. So we have extreme and skewed. So we have extreme value and skewed. What is extreme? So extreme value in data handling statistics will be your lowest and the highest value. It just doesn't fit within the data, the extreme value. Okay? Does that make sense? I mean, imagine in a class, everyone gets 50, 50, 50, 50. Suddenly someone gets 2%. I mean, 2% is extreme, which is the lowest from the whole of the class. And imagine in a class, everyone gets 40, 30, 40, 30, then someone gets 99%. 99% can be an extreme value. The extreme values, what do? They can actually affect your mean. Because think about this, if in between I have smaller values, then someone gets 100%, the average can be higher. So it can really affect your average. And also imagine if I have 3%, then the 40s, the 3% will lower the average. So the extreme values, which can be the highest one and the lowest one, they have an impact on your average. Okay, fantastic. Hope this makes sense, which is your extreme value. Now let's look at skewed. What is skewed? Skewed, we might have data which is skewed. If you look at the median, which is the middle of your data can be on, let me draw, let's say the median is here. We have median, which is there, which is the middle. So more of your data can be this side, which is more of the data, and let's say equal actually. So you have same, this side of the data is the same as this side. So that will be symmetrical because there's the median, this side is the same as this side. It's symmetrical. But now, what if this side is not the same as that side of data? So that is skewed. So it could be skewed to the left or skewed to the right, depend how I move my median. If I move median there, it will be skewed to the left. If my median is somewhere there, it's skewed to the right. Okay, so skewed is about the distribution of the data. Okay, that makes sense? It implies you can have more students getting above the average, or more students getting lower marks, which are skewed to the left. Okay, fantastic. Hope this makes sense. The extreme value and skewness. Okay, but we'll discuss this in details later also. So we're going to look at our 5-number summary. We'll look at range, the box and whisker plot, interquartile range, and these are the measure of dispersion. And this part focuses mainly with our quartiles. Okay. So 5-number summary. Now we're going to look at 5-number summary. So what is this 5-number summary? 5-number summary is just a way of summarizing data using 5 values. I don't want data, as you present data to people, you're not going to give them 100,000 of data. You're just they want 5 summary. What is 5 summary for the data? We want the lowest value. We want the highest value. Okay, let's look at that. You want the minimum, the lower quartile. And remember, the lower quartile is actually 25% of your data. Okay, does that make sense? It's the quarter of the data. So the minimum value, lower quartile, then median. median, which is the middle number given set of data, okay, which is actually the first 50% of the data, which is a median. Then followed by the upper quartile. So the upper quartile, from minimum value to the upper quartile, or Q3, it's 75% of the given data set. Okay. Then we have our maximum value, which is the last one. Okay. Why do we need this? Instead of presenting 1,000 data sets, you calculate the 5-number summary, and from the 5-number summary, we can do some analysis and arrive at some conclusion. Does that make sense? Okay, beautiful. So, what is the median value? So, the median is Q2. Okay. The median value is denoted by Q2 for us. Is the middle number once the data has been written in order. Written in order, we mean from the lowest value to the highest value. Then the middle one is our second quartile, or the median. Okay. If there are n numbers in order, the median lies in position half n plus 1. Okay, what is n? If I have 10 set of data, n will be 10. So it's 10 plus 1 is 11. 11 divided by 2 will be 5.5. Then position 5.5, I'll find my median. I will use this formula if you have a large data. If I have a small data, I can arrange from the smallest to the highest and actually find my median. Okay, makes sense. Then now let's look at the lower quartile. This value lies 1/4 way through the ordered data. So we have the median. Then from the minimum value to the median, I find the median. That median, we call it the lower quartile, or Q1. Also, we can use a formula to find the position of the lower quartile, or Q1, which is quarter is n plus 1. When n is 1, when n is the set of data, if n is 10, you put 10 there, divided by 4, that will give you the position of the lower quartile. Or you can just arrange the data, then the lower quartile, you'll find the data point there. Okay. So now let's look at the upper quartile, or known as Q3. So this lies 3/4 way through the distribution. Distribution means the data. Does that make sense? So we have lower quartile, which is the quarter of the data, median 50% of the data. Then 3/4, we get the upper quartile, or Q3. We can use this formula also to find it. 3/4, n plus 1. N is the size of the data. Then that value gives you the position of the lower quartile. Then you actually go and find it there. Okay. So guys, I hope it makes sense. So we'll see you after the break, and we'll continue with 5-number summary. Fantastic. Welcome back once again. So we're still on our 5-number summary. We have looked at the lower quartile, the second quartile, which is the same as the median. Very important. which is Q2, and the upper quartile, which is Q3, or known as the upper quartile. What about the last two? So we said 5-number summary, so we need 5. Okay, let's look at the last two. So we have what is known as the minimum value. So this is the first number once the data has been written in order from the smallest to the highest, therefore that's the minimum. Okay. Then our last 5-number summary is called the maximum value, and this is the last number once the data has been ordered from the smallest to the highest. Okay, so let's look at this 5-number summary. I'm going to try and draw this for you. So it implies we have a minimum, min for minimum, then we have maximum there, then we'll have Q1, which is lower quartile, we'll have Q2, we'll have Q3, which is the upper quartile. And if you look at this, from minimum to Q1 is 25% of data. From Q1 to Q2 is 25%. From Q2 to Q3, another 25%. And Q3 to maximum, another 25%. What does the 5-number series do? Divides the set of data into quarters, or 25. But what is interesting, look, between Q1 and Q3 is 50% of the data. Okay, between Q1 and Q3, okay? Remember, we might have extreme values. I mean, I might want to say, you know what, I'm going to focus from Q3 to Q1, which is the middle of the data. Because think about this, if I have to calculate a range using the smallest minus the minimum, it might not really give the sense how the data is distributed. But what if I focus in the middle? I might get a sense of what is happening in the middle or how the data is distributed. Okay, fantastic, guys. This is our 5-number summary. Okay, so what are you going to do? Now we have an example here. So the ordered age of 12 brides marrying at registry office in the same month in 2015 were 21, 24, 21, 24, 25, 25, 27, 28, 31, 34, 37, 47, that. Okay. So what we want to do is to find the 5-number summary. The data has already been ordered for us. We can tell the minimum value, which is 21, the maximum value, which is 61. Okay. So let's look at this. So, okay, so what we have here, we have 12 brides marrying at the registry office. So we're given the months. Okay, so this is the data. The minimum is 21. The maximum is 61. We have to find our 5-number summary. So let's see. So what you're going to do is start with the median, okay, which is Q2. And how do we find the median? The median is the middle one, okay? So you can arrange your data from the smallest to the highest and find the middle number. Or what you can do, you find the position of the median. So the position of the median, which will be a half. What is the data set? This is 12. 12 plus 1 is 13. 13 divided by 2, it will give us 6.5. Okay. Then you count 6.5. This is 1, 2, 3, 4, 5, 6. 6.5 is between 28 and 31. This is how we got the 29.5. So which is 28 plus 31 divided by 2, it should give you 29.5. So 29.5 is our median. We just used a half n plus 1 to find the position. You don't have to do that because you have a small set of data, you can find the middle, okay? Because if you have 12, the middle is about 6.5. Okay, does that make sense? Because you have 6 this side, 6 that side, the middle is just after 6. So our lower quartile is 29.5. Then Q1, we can find it there. Okay, where I've highlighted. So it's between 25 and 25, which is actually, because this is the median from there to there. So it's 25 plus 25 divided by 2 by just looking. Or you can go, okay, quarter. What is data size? 12 plus 1, which is 13. 13 divided by 4 will give us 3.5. Then you find position 3.5 is there. It's between 25 and 25. Then what do? You say 25 plus 25 divided by 2, which will give us 25, which is our lower quartile, or Q1. What about the upper quartile? We have to use the last 50% of the data to find the median of the last 50%. Okay, does that make sense? You can do it by inspection, by just looking at data and say, okay, there's the upper quartile. Or you can use the formula 3 over 2 n plus 1. Okay. So what do you do there? You can say 3 over 4 n plus 1. If you do that, where n is 12, you should be getting, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. You should be getting actually 9.5. So 9.5 from here, it's a position, just indicates position. Go to position 9.5 and find the upper quartile or the Q3. Then what do? It's 37 plus 43 divided by 2. That will give us 40, which is our upper quartile. Okay. Are we fine? So Q1, Q2, Q3, those are our quartiles. Okay. Then we can find the minimum value and the maximum value. We know that the minimum value is 21 and the maximum value is 61, which is the highest. We have our 5-number summary. So it's better to have this than having a raw data, you know. I can do some analysis with 5-number summary. Okay. So what are we going to look at now? We've looked at 5-number summary, which is our quartiles with a minimum value and the maximum value. We'll still look at something called the interquartile range. So the range also, then the box and whisker. We need the 5-number summary to draw something called the box and whisker. And we know what are quartiles now, okay? And there's also an interquartile range. So this are called the measure of the dispersion below, and the measure of central tendency, okay, which is mean, median, and mode. There are more. So let's look at the box and whisker plot. So the box and whisker plot is another way of representing data, but representing data using the 5-number summary only. Okay. You don't want to write a report with 10,000 of data. You want to write a report, right, giving 5-number summary. Okay. That's what we need, okay, to do some analysis. Giving me 100 data set doesn't mean anything, okay, unless you analyze that or represent the data. So let's look at the box and whisker. So we say it's a graphic representation of 5-number summary, which is the minimum value, our lower quartile, and median, which is known as Q2, and also as the upper quartile, which is Q3, and our maximum value. Okay. Are we all together? So we're talking about the whisker plot, which we're going to draw it now. To draw the whisker plot, we need what? The 5-number summary to draw that. Let's look at that. So the box plot or the whisker plot is useful when comparing 2 or more sets of data. What does it mean? I might want to compare male and female. How do they perform academically? So I need 2 sets of data, how females are performing in schools or male, then have 2 whisker plots for that. So it's very useful if you have 2 sets of data to compare what is really happening. Okay. So guys, after the break, we'll draw a whisker plot using our 5-number summary and see what it looks like, okay? I hope to see you again after the break with the whisker plot. Great. Welcome back once again, guys. So we're still on whisker plot. Now what we want to do is to draw an actual whisker plot and see what it looks like. And what we said, whisker plots are useful, for comparing 2 different sets of data if you want to see how they're distributed. Okay, let's see this. So we said our whisker plot has the following: the minimum value, which is the lowest, the lower quartile, which is Q1, and Q2, which is the median, Q3, which is the upper quartile, and the maximum value. And the maximum value there. Okay. So so we'll put the actual minimum value there. We'll put the actual Q1, the actual value which we'll calculate there, and Q3. And this actually are called the whiskers. Okay. Remember we spoke about distribution. Okay. So if we have a whisker plot and this area, this part is the same as that part, it's symmetric. Okay. But if this area is bigger than that, it's actually skewed to the right. Okay. And also could be skewed to the left because the median is somewhere this side. Okay. So we can see skewedness if we have drawn the whisker plot. That's another way. If you have data, it might be difficult, especially a big data, to tell whether the data is skewed to the left or right or symmetric. So whisker plot, a useful way to tell the skewness. Okay. Now let's look at drawing one using raw data. Okay. So this is what we have now. We have drawing whisker plot, we have raw data. We've rearranged data from the smallest to the highest, okay? So the minimum value is 3. That's the minimum value, 3. The maximum value is 15, okay? What is the size of data? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Very important. So you have 11. Now, where is the middle? 5 this side, 5 this side, I'm left with 1. Therefore, that is the median. What is the median here? So the median will be 8. You can see that because that's the middle one, which is our Q2. Then from the median to the minimum value, find another median. The middle, another middle. From median to the lowest value. If you see that, we see 4. Which is our lower quartile, okay, or Q1. Then from the median to the maximum, the last value, we calculate a median. Okay, the middle value, which is Q3, but it's known as upper quartile or Q3, which is the same thing, which is actually we're getting 10. Can you see that? So if you look at that, this is what we have there. Q1, it's 4. Q2, 8, Q3, 10. Those are our 3 quartiles. Is our number summary done? No. We need minimum value and maximum value to have our 5-number summary. So our minimum value will be 3, our maximum value will be 50. Okay, so let's look at that. So minimum value, I need to write that, which is 3, maximum, which is 15. Okay, I need that as part of 5-number summary. Now let's draw the Whisker plot. So there I start with the median. I know that the median is 8. Put a line there. My median is 8. So I draw a box. Okay. Then I have numbers from 3 to 15, which is my data set. Are we together? And I draw a box. And I say, what is the median? The median is 8. And I put a line there. And I say, what is the lower quartile? The lower quartile, we know it's 4. Then there's 4 there. Put a line. And what is the upper quartile? We know that the upper quartile is 10. We connect. So this actually connects the box. Are we together? So lower quartile, median, upper quartile forms the box. And in the middle is your median, or Q2. Now let's complete our Whisker plot. We have not used what? The minimum value and the maximum value. And we know that the minimum value is what? Is 3. And the maximum value is what? 15 from our data. So our minimum value is there, and our maximum value is there. So this is what we do now. We connect our minimum, and we connect our maximum. Can you see that? This is our Whisker plot, if you look at it. So if you look at the Whisker plot, where's the Whisker plot? To the right, to the left, or to the right? You can see it's to the left. So it's negative skewed. Does that make sense? So we can tell the skewness of data if we have the Whisker plot. We cannot really tell, you know, unless you guess. But rigorously, if we have the Whisker plot, I can tell the skewness. I can see the skewness is skewed to the left. Great, fantastic. Now we've looked at 5-number summary, we looked at quartiles, we'll look at range, which is maximum minus minimum. We'll look at interquartile range. Whisker plot, very powerful. We looked at that, which is from 5-number summary to draw the Whisker plot, and measure of dispersion, and measure of central tendency. So we're going to look at range. So these are the measure of dispersion, okay, which is the range. What is range? Range is the maximum minus the minimum, and the interquartile range and the semi-interquartile range. The interquartile range is actually your Q3 minus Q1, the upper quartile minus the lower quartile. Together, define this now. So range, the range is the highest value and the lowest value score can be useful in deciding who is more consistent. Okay. If we have the minimum value and the maximum value, we can decide it who is more consistent by using the two values. If we minus the highest minus the lowest, if there's a higher deviation, there's some inconsistency there. But the highest minus the minimum, if the deviation is not that big, there's some consistency in the data. Okay? Are we all together? By using range. So the lowest score subtract from the highest score is called the range. Remember that the range is not an average, but a measure of spread. How the data spread? Does that make sense? Is the data close to the mean or far away from the mean? Is everyone in your math class close to the average? There's some people, if the average is 50, but they get 90, far away from mean. If the class average is 50, there's some people close to the mean. They're getting what? 51, which is close to the average. So the range tells us how the data actually spread. Okay. Now let's look at the range. We can say the range is the maximum value minus the minimum value. Okay. If the scores are spread out, then the range will be higher and the score less consistent. If the scores are close together, then the range will be lower and the scores more consistent. We've discussed that. Okay. The range can be given by maximum minus the minimum value. Range is not a good measure of spread because one extreme, very high or low value, can have a big effect. Does that make sense? Because you might have set of, let's say in the class, there's just one person who had a bad day, a difficult day, and got a lower mark. And there was someone with 99, and we calculate range, and we get range is 98. Maybe that person got 1%. But everyone performed good. So range can really mislead us. Does that make sense? It's not a good measure of spread. Okay. But it's very useful sometimes. Okay. So now we're going to, we looked at quartiles, we looked at range, Whisker Plot, which was part of a measure of dispersion, which is the range, and interquartile range, and semi-interquartile range. So let's look at semi-interquartile range. This measure of spread is like to be the median. So the interquartile range is actually the range of the middle 50% of the data, the half of the data which is in the middle, which is actually finding the range for that, which is the interquartile range. So the difference between Q1 and Q3 will give us the interquartile range. So we need the value of Q3 minus Q1. Remember that this is the lower quartile and this is the upper quartile, which will give us the interquartile range. Okay? It's the same as the range, but we're not using maximum and minimum. We're using our quartiles to find range. Okay. Now, interquartile range, we can find it from the Whisker plot. If you have a Whisker plot, remember our min there, our max there, and this is Q1, and this is Q2, and this is Q3. So interquartile range is that part, which is the 50% of the middle data, which is Q3 minus Q1. Okay. Interquartile range. The interquartile range is generally a better measure of spread because it is not affected by the extreme. Think about this. So the interquartile is not affected by the extreme. What are the extreme? What do we say this extreme? You can have someone who gets a high mark in class or someone who gets low mark on the data set. Those are the extreme. So if I use range and I say 100% minus a 10%, I mean, does it really tell the deviation in the spread of the data? No. But if I use quartiles, I use the middle from Q1 to Q3, I calculate the range. That can really tell us the spread of the dispersion of the data, okay, which is far better than the range. Okay. So we have looked at quartiles, we have looked at range, Whisker plots, and measure of dispersion, and which is measure of central tendency, and here is measure of dispersion. Okay. Now let's look at semi-interquartile range. Okay, so this is the semi-interquartile range. The semi-interquartile range is the half difference between the upper and the lower quartile. So the half difference between Q1 and Q3. So semi-interquartile range is half the upper quartile minus the lower quartile. So it's actually interquartile range divided by 2, which is the same thing. Does that make sense? So if I find the interquartile range, I divide it by 2, I get semi-interquartile range. Remember, semi means half. So in half of interquartile range. Okay, are we all together? Which is half Q3 minus Q1, which is our interquartile range. So interquartile range. So the semi-interquartile range is not affected by extreme scores also. It is a good measure of spread for skewed data. Remember, skewed data, it implies it can be skewed. Let's say the average is 50, but lots of people can be getting the 90s, or you can have lots of people getting lower mark, which is skewed to lower marks. So semi-interquartile range is a good measure of spread, okay? And also the interquartile range. And range, not really, okay, because it can be affected by the extremes. Semi-interquartile range and the interquartile range are not affected by the extreme, the highest and the lowest set of data, okay? Fantastic. So we have looked at quartiles, semi-interquartile range, we've looked at range, we looked at Whisker plots, and the measure, this is a measure of dispersion and measures of central tendency. So measure of central tendency, they cluster around the mean, and measure of dispersion studies how is the spread of the data. Does that make sense? We want both, to study both, okay? So there is a question to try, okay? So find the mean, median, lower, find median quartiles for the data below. So what do? We have to arrange data from the lowest to the highest. Let's do that together. So I'm going to try my lowest. I see it's 4. I'm going to put 4 there. Then what is the second data? I have another 4 there. It's important to cancel the data if you've used it. I have 4 there. With next one, which is 5, which is 5 there. Then what else? Oh, there's 6. Then I have 6. After 6, what can I put? I have 8. Another 8 there, another 8 there, which I have there. Then what else do I have? 9, 9, 9. How many 9s are there? I have 1, 2, 3. Okay, 9. And we have what? 10, then 12. Then we have 10 and 12. How many data sets do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let me write this. It's 4, 4, 5, 6, 8, 8, 8. Okay? 9, 9, 9. Then we're going to put 10 and 12. So it's arranging that from the smallest to the highest. So the minimum value, we start with our min, which is 4. That's what I prefer. The maximum value, which will be what? Which will be 12. So our max is 12. So max is 12, minimum 4. Then now we have 12 set of data. Are we all together? Where do I find the median? 6 that side, 6 that side, I find the middle. So 1, 2, 3, 4, 5, 6. So the middle is there between 8 and 8, which is Q2. How do I do that? It's 8 plus 8 divided by 2, which will give us 8, which is our Q2. Then how do I find the lower quartile? The lower quartile will be the middle of the half of the data, which is there, which is 5 plus 6, 5 plus 6, which is 11, divided by 2, which is 5.5, which is our Q1, which is 5.5. And what about the upper quartile, which is 1, 2, 3, which is between 9 and 9, okay, which is 9 plus 9 divided by 2, which is 9, which is our Q3. So I have the 5 number summary. Okay, guys, so I hope this makes sense. We have our 5 number summary. I hope you enjoyed the lesson, and we hope to see you soon, and good luck.